Okay, moving on from modulus equations, we're now going to look at some inequalities with moduluses in them. And this should remind you a little bit of when you did quadratic inequalities, where there are two stages. You had to find the critical values, and then you had to consider a graph to find out where you needed to be in relation to those critical values. So the critical value part, we're just solving a modulus equation. So for the critical values for this one, giving myself a little bit of space here, okay, all I have to do is solve the equation x plus 2 is equal to 4. Now we saw before that sometimes it was helpful to draw the graph, sometimes I could solve the equation without the graph. Now I could solve this equation without drawing the graph. It's a very simple one. Remember, either the modulus has an effect or no effect. If it has no effect, then x plus 2 equals 4, which gives me x equals 2, or the modulus could have an effect, in which case it's minus x minus 2, which equals 4, in which case minus x equals 6, so x equals minus 6. And that was all very fine and pleasant, but it doesn't really help me solve the inequality. So what I now have to do is draw the graph. And the moral of that is I might as well have drawn the graph first, because we've seen it can be helpful in solving the equation. This one was easy, but why not just get the graph out of the way first? So what does the graph of x plus 2 modulus of that look like? Well, it's the modulus graph with a translation of 2 units to the left, because I've added 2 inside. Or I could use the point of v method. The value that makes the modulus equal to 0 is when x is minus 2. So the point of the v is going to be at minus 2, in which case if I let y equals modulus of x plus 2, if I'm looking at x equaling minus 2, I'm going to get the point minus 2 naught. And of course the y-intercept of this, when x is 0, I'm doing the modulus of 2, so the y-intercept is 2, so I get the graph looking like this. Okay, now the other graph I need to consider, which I've not quite left huge amounts of room for, but I'll be alright. This is the graph of the graph of y equals 4. So I'm plotting this number and this expression as my two graphs. So unlike the quadratic inequality, we're now comparing two graphs. Okay, my scaling isn't very good. 2 doesn't look really like half of 4, but it's good enough for me to find out what's going on. From having solved the equation, remember, sketching the v-shaped graph, the two halves of the v-shape are going to be y equals x plus 2 when the modulus has no effect, and y equals minus x minus 2 when the modulus does have an effect, and equating those two things to 4 is exactly what I've done over here. And the x values I know are 2, so this is an x value of 2 for that intersection, and this is an x value of minus 6, and that kind of looks more or less alright. So I want x plus 2 to be less than 4. So I'm now comparing two graphs. So where is the graph of modulus of x plus 2 less than the graph of 4? Well, an example point would be here. Here, the y-coordinate, the output for the modulus of x plus 2, okay, is somewhere less than 2, but 4 is up here, so this value is clearly less than 4. So I'm comparing y-coordinates. One way to think about this is the graph that's bigger, it's possible to stand on that graph and drop stones on the head of anyone standing on the other graph. So here, okay, I want the 4 to win. I want the x plus 2 to be less than 4, so 4 is bigger, so I say 4 wins. So here 4 does win, because standing on the 4 graph, I can drop stones onto the heads of the other people. But if I go past this point, now it's someone who's standing on the modulus graph, on the v graph, that's bigger, they're higher up. They could drop stones on my head on the 4 graph. So this is the part of the x equals 4 graph where the 4 actually is bigger than the modulus of x plus 2. Or if you prefer, this is the part of the modulus of x plus 2 graph where it's below, where it's less than the 4, which is what I want. So I can see from that argument that the inequality is solved for values between minus 6 and minus 2. So all I need to do, I need to find my critical values. There they are. And then I need to say from the sketch, I need values of x between minus 6 and 2. And it's a strict inequality, so I'm not allowed to be there. I'm not allowed to be there because the values aren't allowed to equal each other. So minus 6 is less than x is less than 2. I don't have equals's on those inequalities. And that is my final answer to my modulus inequality.